Most candidates completely overthink this problem. They start imagining dynamic programming. Some even try backtracking. But the entire problem collapses into a single observation. One line of logic. And this is exactly the kind of problem that filters candidates in interviews. If you miss the insight, you struggle for 20 minutes. If you see it, you solve it in 30 seconds. 1689. Partitioning into minimum number of Deci-Binary numbers. Category: greedy, goal. Given a decimal number as a string n, return the minimum number of Deci-Binary numbers needed to sum up to it. Now pause. What is a Deci-Binary number? A number where every digit is either 0 or 1. Examples: 0.101.1100.1.0. Invalid 0.2.9.345. So the question is, how many 0 or 1 only numbers do we need to add together to get n? Hidden signal detected. Decode the constraints. This is about digit contribution. N can be large, up to 100,000 digits. We're given it as a string. We're minimizing the number of Deci-Binary numbers. Whenever you see large constraints, minimization. Digit by digit logic. That screams greedy. Let's see why. Example walkthrough. Take n equals 32. What does that mean? 32 equals. Let's think digit-wise. We need to build 3 in the tens place. We need to build 2 in the ones place. Each Deci-Binary number can only contribute, at most 1 per digit position. So if the first digit is 3, that means we need at least 3 Deci-Binary numbers. Because each one can only add 1 to that column. Wait. That's the entire insight. D in n. That sink in. If a digit is 7, we need at least 7 Deci-Binary numbers. Because each Deci-Binary number contributes at most 1 in that digit position. So what determines the answer? Not the sum. Not combinations. Just the maximum digit in the string. That's it. Many candidates try to simulate building numbers. Subtract until 0. Count layers. That works, but it's unnecessary. Because the maximum digit already tells us the minimum layers required. This is classic greedy compression thinking. The minimum number of Deci-Binary numbers required is the maximum digit in n. Why? Because that digit forces that many layers. And all smaller digits will automatically be satisfied within those layers. Example: n equals 82734. Digits. 8, 2, maximum digit 7 equals 8. So the answer equals 8. Because you need 8 layers to build the 8. The 7 fits within those 8 layers. The 2 fits. Everything fits. Greedy works because digit contributions are independent per column. That independence is the invariant. We define our function minpartitions that takes a string n. First, we initialize a variable max_digit to 0. Then, for each digit in n, we update max_digit to be the maximum of itself and the current digit converted to an integer. If max_digit reaches 9, the largest possible digit, we can immediately return 9. Finally, after checking all digits, we return max_digit as the answer. And here's the concise Python version. Return int max n. This simple line captures the entire greedy insight. The maximum digit dictates the minimum number of Deci-Binary numbers. Why iterate through the string? Because the input can be huge, we don't want to convert the entire number to an integer. Next, max_digit tracks the largest digit encountered as we scan. Early stopping at 9. Digits range from 0 to 9. If we see 9, that's the maximum possible answer. No need to continue scanning. This is optimization mindset in action. Complexity analysis. Time complexity. O(n). We scan each digit exactly once. Space complexity. O(1). Only one variable stored. This is optimal. You cannot do better than O(n), because each digit must be inspected. They're testing. Can you spot greedy? Can you reduce problem dimensionality? Can you avoid simulation? Common follow-ups include: what if digits could go beyond 9? What if Deci-Binary allowed up to 2 instead of 1? What if we had weighted contributions? Notice something powerful. This problem is about recognizing column independence. That's a common greedy theme. Similar problem family includes gas station greedy feasibility, jump game, partition labels, Medium problems often filter here. Because many candidates overbuild solutions, the interviewer watches for this moment. If I give you n equals 11111, answer? If I give you n equals 909, answer? If that feels obvious now, you just unlocked the greedy layer perspective. Comment below. Did you initially think dynamic programming? Be honest. Today's key insight: when each layer contributes at most one per digit, the largest digit determines the minimum layers. That's greedy compression thinking. This pattern appears whenever contributions are capped. Columns are independent. We're minimizing layers. Train yourself to look for the dominant constraint, because that's where interviews are won. If this clicked, you're not just solving medium problems. You're thinking strategically. See you in the next breakdown.